Okay, let's get started. Hello, everybody, and welcome to the community monthly meeting for Chaos Mesh in June. And I'm Kelvin. I'm really glad to be your moderator tonight. Today, of course, I think so far as I can see, the attendees tonight are from China. So to the attendees tonight, happy Dragon Boat Festival, because it is a festival today. No matter if you're with your family or not. Okay, before this meeting, so there's two things I would like to mention. First, please keep yourself on mute unless you're speaking. And second, this meeting is recorded and the video will be uploaded to YouTube after the meeting. And also, today joined with me are Bella Shan. She will be taking notes for the meeting, and others are the maintainers and the contributors of Chaos Mesh. And I think we have some first timers here. So for the first session of the meeting, we would like the new attendees, the first timers, to say hi to everybody and give an introduction about yourself. So I think, let me see. We have Nan. Welcome to the meeting. Could you please introduce yourself? Hi, Nan.
Hello, can you hear me?
Yes.
Okay, hello everyone. My name is Nan. So this is the first time I joined this meeting. So just out of curiosity, actually, so I just recently, we are adopting the TiDV in our company, and yeah, then I found out the Chaos Mesh is quite interesting. So yeah, I want to contribute. I work in Ninja Van, which is a logistic company based in Singapore. Yeah, that's it. Thank you. Happy to meet, like not really meet, but know everyone. Yeah, thanks.
Thank you, Manan. It's really exciting for you to be here, and also we're looking forward to, see your contributions to Chaos Mesh. And
yeah, thank you.
Thank you. And we have Yang Yue. Yang Yue is actually he will be presenting later. So Yang Yue, would you please just say hi to everybody and introduce yourself?
Yeah, no problem. Yeah. Hi everybody. My name is Yang Yue, and I'm the original author of the Chaos Mesh dashboard, and I'm glad to be a contributor of Chaos Mesh. And also, I'm working at Mmap and is a member of this company. So that's all. Yeah.
Yeah, thanks. We're looking forward to your presentation later. And do we have anybody else who's first timer here? I don't think so. If I missed you, just you can just feel free to introduce yourself. Okay, let's jump into the agenda today. For today's meeting, firstly, as usual, we have the technical progress updates as well as community updates from Chen, in which will include this demo session, a mini demo session from Yang Yue and about Chaos Dashboard, which is really exciting. And after that, we will have the usual community sharing session, which will be presented by another maintainer of ChaosMesh, Yang Keao. The topic is implementation of time chaos, which is a really cool feature of ChaosMesh. And then after that, we will have a Q&A session, which the whole meeting will last for 40 to 50 minutes. Okay, without further ado, let's get started. And let's start from the technical progress updates. Chen, do you want to share your desktop?
Oh, okay. I will share my screen.
Okay. Then
First, you
my sharing.
need to return your screen.
Yep.
Okay. Wait. Sorry. Okay. Can you see my slides?
Yes.
Okay. Okay. Hi, I'm Chen Wen. Today and here, and this introduction will include two parts. The first part is I will will introduce some recent updates on ChaosMesh, and the second I will invite Yang Yue to show a simple demo about the Chaos dashboard. Yes, and Yang Yue is the primary author of the Chaos dashboard. Yes. Okay. Okay, the first is about the chaos operator. This month we don't have big feature about this, but I think these two small change point should be known by us. The first is then we use the environment variables to define all configs and unify all configs with the chaos dashboard. Yes. The second change point is we use the waiting phase instead of the finish phase. This which is defined in the stand of the chaos object. As you know, we can define the cron scheduler in our chaos experiment. So when a fault injection is over, it doesn't mean then the whole experiment is over. But waiting for the next failed injection. So we use the waiting feather instead of the finish. Yes. Okay. The next is about a website. Yes, this month we publish our ChaosMesh website. Here is our website URL. Can we clean? Okay, let's check it. This website we include two parts. The first part is the document, and here is our ChaosMesh document. The second part is blogs, and here is the published blogs. If you want to, you have some article want to publish and our website, you just to submit your article to our repo. Yes. And here you can see our website is very new, and we are looking forward more contributors to help us improve it. And you can find the source code in the ChaosMesh repo. Yes, and here. Yes, this is the source code. And in this directory, if you have some idea about our website, you just put a PR to improve it, and maybe you some idea also can put a issue. Let's discard it. Yes, let's return our slide. Okay, next, we also add contributing guidelines. This shows the steps about how to submit a PR to ChaosMesh. In addition, we also provide a development guide in our document and to help the contributors to participate in the development of the ChaosMesh project. And here, if you want to get more updates, you can find in our web lead update. And here is the URL. Yes, the last, I will invite Yangyue to show a simple demo about the Chaos dashboard. Yangyue is the primary author of the Chaos dashboard. Yangyue, are you here?
I'm here, yeah.
Okay, I will return my sharing. Okay.
Yeah, wait a moment. Right. I'm going to share my screen. Can everyone see my screen?
Yes.
Okay. Okay. Today I will take you a tour of our latest progress of ChaosMesh dashboard. Before the tour begins, you may want to ask why we want to build a dashboard for ChaosMesh. The answer is very simple, because we don't want to enter the commands in the shell every time when we operate the experiments. Easy to use UI interface can also help users to get started with ChaosMesh more quickly. And this tour, I will focus on the feature of create experiments. After created, I will show you how the experiment influenced the existing code. So let's begin. And you can see this is the dashboard interface. As you can see, also there is a new experiment button, and we click it. After clicking, a drawer will slip in. The form inside it can help us to define our experiments. At first, we start to type an experiment name. For this time, I want to test the impact of network latency. So I named it to network delay test, and we will pass the namespace to default and click the next button. We need to fill the scope info, so I will set the label selector to ATP web show. This tells us the experiment will soon apply to the app of web show, and click the next. This form, I will choose the network and select the action to delay. And I'll set the latency to 30 milliseconds and click the next. Yeah, in this form, I need to tell the chaos when to run. You can define an immediate job or a scheduled job, and the immediate job is the default option. In this tour, I will use the schedule job, and we need to set two fields to define the schedule. So the one is cron and the another is duration, and I will set the current field. Yeah, I've set before to every 5 minutes. This means the experiment will run every 5 minutes, and duration I will set it to 30 seconds. This means the experiment will last 30 seconds, and click the finish button to submit the experiment. Yeah, you can see there is a loading icon, and it tells us the experiment is running. And I will use another demo to verify that this experiment is already created successfully in there. The demo is called Web Show. It will show the current network delay. And as we can see from 1050, the network latency is up to 30 milliseconds. This experiment has been already injected here. And reflect our created experiment detail. Yes, I click here. Yeah, in this timeline panel, you can also view its start time and finish time. Yeah. So this is our most important feature of Chaos Mesh dashboard. With dashboard, we wish you can easy to create an experiment and with status. This is a goal we want to achieve. And currently, we are still continuously optimizing the entire dashboard. For example, we want to add a feature to let you create an experiment from a YAM file. And also in events page, we hope to enable users to quickly locate an event. For example, after I click the detail button, the event detail will show on the screen. Yeah, this is also something we are trying to do. Yeah, okay, this is the current state of Chaos Mesh dashboard. We will hope it can be officially released in version 1 of Chaos Mesh. Thanks to everyone, and this tour is over. Yeah, I will stop my sharing.
Okay, I have some comment here. Yes, in this month, we also have a Chaos Mesh and data source. Yes, and here, our Yeben will want to make a quick demo about the data source. This data source is designed. Yes, this is a data source.
Hi, Chenwen.
Huh?
Hello, Chenwen. Before we start the next demo, because we already have 2 sessions of updates, we want to ask everybody, do they have any questions? Yes.
Yes.
Yeah.
I just make an introduction about this. Yes, because this is also an update. Okay. Or I just make an introduction about this, and this data source is the Grafana data source, and we can use it in Grafana and select our event and show this in our in Grafana with the annotation. Yes, and here I just yes, okay.
Okay, I think there's really cool updates from Chenwen and Yang Yue about the documentation website and the Chaos dashboard. I think which they will really improve the ease of use and the observability of Chaos Mesh. So do we have any questions? Because I know everybody, a lot of people are interested in, especially in the Chaos Mesh dashboard. Okay, I take that as a no for now. Yeah, you can ask anytime if you have any questions. Now we are glad to add another quick demo for the data source by Yeben. Hi Yeben, would you please?
Hello, can you hear me?
Hello. Yes.
Yeah, okay, okay, let me first share my screen. Wait a second, please. So can you guys see my Google Chrome browser? Okay, so
Yes.
so I already like started the Chaos Mesh source. It's quite new, and it's still like experimental and in progress. But yeah, we can already like try its like very basic functions. So here, yeah, let me first delete this source. So if we want to install the source, you can first find the plugins. Here you can search the plugin's name. Yeah, you can find it's the Chaos Mesh. And yeah, here we don't have any README here, so it's just a template README. I will improve later. Then after you can find this plugin, you can add a source for it. Let's see, you can add Chaos Mesh. So and this URL is the like the address of your Chaos dashboard instance. So here I'm using this one. So and get a test. So it says the source is working. And here, let's see, we already have a. Okay, let's skip this panel. So our first, these Chaos Mesh source, we can display all the events here. You can see there's like query editor. So you can choose chaos kind. So just 6 kinds of chaos we are supporting currently. So let's choose network chaos, and the namespace, let's choose chaos testing. And here, so because my my front end skills are not very good, so I'm still working on the auto suggestions and from the events API. So here, our users need to type the experiment name manually. So, well, okay, and let's switch to table view, and we can display like all the testings here, all the experiments here. So, but it has some like problem currently because our current events API doesn't support this from the uh, list filter by the like start time and end time. So this is not supported currently. And yeah, this maybe just a bug. Yeah, that's what happened in live demo. So, and let's do another thing here, and I will show you the annotation feature. And here we can also add annotations for it. Let's see. And so yeah, so you can see there's already an annotation list here representing the chaos events, but the problem is, and so let me zoom in the time, and yeah, you can find the event here, like the network kind namespace and the experiment name. Yeah, I think that's all for this demo. And yeah, if you are interested in this project, feel free to contribute to that repo. And yeah, I'm hoping more and more people can use it later. So thank you.
Okay. Thanks, Evan. I Anybody has any comments or questions regarding the previous updates and demos? Okay.
I have a question.
Sure.
Can we add the grandfather into TiDB cluster or something else that have a grandfather? I think we need to unit it first.
Okay. And this project is very new, and we have some other works to do it, and also we have some performance problems. So we must be improve it, and okay, and then we will add it to the TDB Grafana. Yes, and okay.
Okay, thank you.
Okay, the next session is the sharing from Kao about the implementation of time chaos. Okay, Kao.
Okay. Hello, I'm Yang Keao, an intern developer at Mmap. Several months ago, we implemented time skew chaos in Chaos Mesh. This is a very cool feature. Nowadays, some distributed systems are highly dependent on monotonically increasing timestamps. So time skew injection could find or cause deeply hidden problems. In a simpler situation, the implementation is quite straightforward. I believe everyone here knows how to set the system clock. But in the cloud environment, we need to set clock for only one process without affecting others, which turns to be a very difficult problem. Well, you may ask, as we have used namespace such as network namespace to inject chaos for only one process, is there something like a namespace for time? Unfortunately not. Time namespace is only available for kernel version greater or equal than 5.6 and only supports a few clock IDs. So before Linux 5.6, all processes in Linux share the same clock. There are not any provided ways to do this chaos. We have to look for or explore a new way to do this. It may be not elegant, not simple, but it's very twisty and fascinating. In this talk, I will introduce the roadmap of the implementation of time skew. Kubernetes and operator-related concepts will be ignored so that we can focus on how to inject the time skew for a single process. A straightforward inspiration is that we must understand how the process gets time. If we understand the routine, we may find bottleneck to inject our chaos. Here I have listed several different methods. First, you could use system call directly with syscall instruction and 228 syscall number. Oh, I bet that most of you don't write assembly language and don't use syscall instruction directly in 21st century. Second, you can call clock at time function in vDSO, which we will talk about it later. Or mostly, I think you will use functions in the standard libraries for every language runtime, such as instant now in Rust or time.now in Go. This is very common, doesn't it? You can also use external services to get timestamps, such as TrueTime API, which is used by Google in Spanner. After we have investigated the implementation of time-related functions in every different programming languages, we can conclude that clock@time vDSO call covers most situations. But vDSO, we have talked about it several times, which may have confused you. What is vDSO? I will introduce it right now. What is vDSO? It's a mechanism to run some functions provided by the kernel in the user space. It contains several different functions, one of which is clock@time, which we use to get time mostly. It doesn't like other dynamic libraries which are loaded by vDSO. The vDSO is allocated and loaded by the kernel when a process starts. If you read the maps file of a process, you can find this part of memory here. All these functions are organized in a standard ELF format for the convenience to link and parse. As we have mentioned above, if we can inject clock@time vDSO call, somehow modify the return result, we can inject time skew for most applications. Yes, again, just like what we have done, let's analyze the normal call routine of vDSO. I believe the whole coroutine cannot be that safe or solid, so we can find weak points to create chaos. Let me list the whole coroutine of calling a function in vDSO. First, you can find the start address of vDSO in procfs AUXV file. See here, as you can see, the first line is two 64-bit integer. The first one is 0. Oh, the first one is 2, 1, which means the second one is the start address of vDSO. But actually, you can read and parse the maps file in procfs, which will give you the same result as above. After parsing this part of memory according to ELF format, you can find the start address of clock@time function, then simply use call instruction to call it. All these steps are done automatically in language runtime or libraries now. And finally, the procedure in vDSO clock@time function will run and returns. As you might have noticed, the running process and clock@time function are both in user space. All the binary codes are in the target process memory space, which means if we can modify the binary codes of clock@time function, we can do anything when a process called clock@time. The ignorant process runs the first step, the second step, the third step, the fourth step, and finally call into the part of memory which can be modified by you. The binary codes are anything for a CPU. It's under your command now. You can even ask it to exit or to kill itself. But that's not what we want. What we want is to simply return a modified time. Now the implementation of time chaos is right in front of you. We can make it jump to a prepared fake function at the beginning of clock@time, which will return the modified time. So we can split the implementation into three smaller questions. One is how to modify the memory in the target process. The second is how to implement the fake function. The third, how to load a slice of binary into the target process memory. For the first question, we will introduce ptrace. You may don't know ptrace, but as a developer, you must have used it. Most functions of GDB, such as setting breakpoints, watching, and modifying variables, running expressions, they are all implemented with the help of ptrace. In chaos mesh, we will also use ptrace actually. Ptrace poke data to write bytes to a specific location in target process memory. Then we have to decide the content to write. As we have said, it's a simple jump instruction. Jump-related instructions are quite simple. We can set the RAX register with the target address and then jump to it. The left part is the instructions and the right part is the corresponding binaries. You can compile it with the instruction manual and your smart brain. The red lines are the target address, which is a 64-bit integer. Now we have solved the first question. After calling the clock at time, the process will jump to the prepared function. Then let's solve the second question, how to implement the fake clock at time function. The main problem is how to get time because the real clock at time has been modified by us. But we have listed several different ways to get time, this will not bother us. Recall the first method to get the time mentioned before. Mentioned here, we can use clock at time syscall. Then we can modify it according to these static variables. The logic is shown here as C programming language. Then we can compile it with GCC and modify some small parts, resulting in the corresponding binary slice of the fake function in the right part. After the fake function has been prepared, the only question is left. How to load this fake function into the target process memory and get the target address of the jump. First, we need to allocate memory. How? Yes, the Mmap syscall will help. We will use ptrace to run the Mmap system call in target process. Let's see how it can be done. We could write 0f05 at our IP address, which means syscall instruction. Then we should modify registers, modify RAX to 9, which means Mmap, RDI to 0, which means the first argument of the Mmap is null, and RSI, RDX, R10, R8, R9 are the following Mmap arguments. Then we use ptrace single step to run this instruction and stop. At this time, the Mmap function call the Mmap system call will be run by the target process, and the return value will be stored at RAX register. Finally, to avoid breaking the target process, don't forget to back up and restore the modified register and memories. After we have allocated memory in target process, we can write the fake function binaries to it now. At this time, we use another syscall called process VM write v rather than ptrace because it's faster and more stable. You may want to know why we don't use process VM write v to modify vDSO. Recall that we use ptrace poke data to modify vDSO to make it jump to a fake function. That's because vDSO part of memory is read-only in privilege, and process VM write v requires the target memory part is writable, but ptrace poke data doesn't require it. Okay, we have solved all these small problems, and the roadmap to implement a time skew is clear now. Let's recall and conclude them. First, load the fake function into the target process and get the start address of fake function. Second, use ptrace to modify variables in the fake function according to the user requirement. Third, use ptrace to modify vDSO's clock at time function to jump to a fake function when the target process calls it. Okay, that's all I have for today. At the time and presentation form limit, you may be still not very clear about the detail of the implementation. I believe the best way to understand it is to use chaos match chaos and read the source code, which is not very long actually. If anyone has any question, please feel free to ask here now, and I will do my best to answer. Is there any questions? Hello?
Okay, I don't think there is any question for now.
Yes.
Okay, thanks, Carl. Yeah, this really is a very hardcore sharing because they all sound Greek to me. But I hope you can, really get something from it. Okay, with that, I think we will come to our end of this community meeting, and we will, if you have any questions about this, what we share in this meeting, or about Chaos Mesh, the project and the community in general, you can ask now. Okay, thanks again for everybody to attend tonight's meeting. And if you're not in our Slack, I strongly recommend you join it here, and so that you can, get informed of the immediate updates of Chaos Mesh. And also, we would like you to, fill in the survey for the meeting if you would like to, which will help us improve the meeting. Yeah, with that, I think it's time to end this meeting. Thanks everybody for attending. Have a good day or good night.
Okay, bye-bye.
Bye.
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 Bye.